Solving trigonometric equations. Now before you have a look at this video, I strongly urge you to take a look at my previous two videos, the first being the fundamentals of trigonometry and the second being trigonometric identities. And this is because, like most things in life, if not all, math is very connected. So we need to understand the fundamentals before we can move on to anything else. So please do take a look at those two videos because in this video especially, we're going to be focusing on past papers. And although that is the case, I will still be going through some fundamentals just to make sure that you are on track with everything and we can move forward smoothly. What exactly is a trigonometric equation? We are all familiar with trigonometric functions, some examples being sine theta, cos theta, and tan theta. Now if we involve any trigonometric function in an equation, this equation will be referred to as a trigonometric equation. So we can take a look at this example. 6 tan squared theta minus 5 sec theta plus 2 is equal to 0. Because this particular equation involves trigonometric functions, it is referred to as a trigonometric equation. And the purpose of this video is to learn how to solve equations like these. Before we can learn how to solve these equations, we must be familiar with some basic trig functions. The first three being from a very famous mnemonic, SOHCAHTOA, sine, cos, and theta, their relationship with the sides on a triangle. So from a right angle triangle, we can see that sine theta is equal to opposite over hypotenuse, hence so. Cos theta is equal to adjacent over hypotenuse, ka, and toa, tan theta is equal to opposite over adjacent. We also need to know that tan theta is equal to sine theta over cos theta. And for these final three, which I definitely gave a very good brief explanation of how we can remember these, but I'll still go over it. The third letter of the the trigonometric functions on the left-hand side corresponds to the first letter of the functions in the denominator. So for example, cosec theta. The third letter in cosec is an S, and the first letter is an S here in sine, okay? So notice S, S, C, C, T, T. So sec theta is equal to 1 over cos theta. Cot theta is equal to 1 over tan theta. So that's a very handy way that you can remember these functions and these particular identities. Alright? A very, very important thing to understand a lot of concepts in math is the graphs of sine, cosine, and tangent. And these are also applicable to trigonometry. Alright? So one of the methods of solving trig equations involves the use of these particular graphs, sine, cosine, and tangent. We're going to try to remember particular values to note, okay? These values are going to help us quickly recall certain things and solve equations much faster than most people would be able to if they didn't know, okay? So, for the sine graph, particular values to note. Between these boundaries, 0 and 2 pi, okay? Y is equal to 1 when x is equal to pi over 2. Y is equal to minus 1 when x is equal to 3 pi on 2. And y is equal to 0 when x is equal to 0, pi, or 2 pi. Alright, so that's the sine graph. Moving on to the cosine graph. It looks like this. Also, know how to draw them. It's very, very easy to memorize how to draw them and the particular values as well, right? So between the boundaries 0 and 2 pi, y is equal to 1 when x is equal to 0 and 2 pi. Y is equal to minus 1 when x is equal to pi, and y is equal to 0 when x is equal to pi on 2 or 3 pi on 2. Alright, and for tangent, the graph of tangent, I always thought this graph was really cool. I find it look real nice, you know, with the asymptotes and stuff like that. For those of you that don't know what an asymptote is, an asymptote of a curve is a line that continually approaches a given curve but does not meet it at any finite distance. So this could get as close to this line as possible, but will never actually touch the line, right? So this is called an asymptote, and we have all of these here are asymptotes, right? So the values to note: y is equal to 0 when x is equal to 0, pi, and 2 pi. 0, pi, and 2 pi, right? So asymptotes occur at these values: x is equal to pi over 2 and x is equal to 3 pi over 2. Moving on to understanding quadrants. Quad means 4, and therefore the Cartesian plane has 4 quadrants. If we were to draw a circle, so we have our circle here, and draw 2 perpendicular lines that intersect each other at the center of this circle, we will then have a model of the quadrants of the Cartesian plane. We can see 4 quadrants here: 1, 2, 3, 4. So it can be seen that these 2 perpendicular lines form 4 right angles. 1, 2, 3, and that's the 4th one, right? So therefore, if we start from 0 and move counterclockwise, we can then figure out the range of theta based on the quadrant that it is in. So we have 0 degrees here, 90 here, 180, 270, and then we get all the way back, and that makes a 360 degrees, okay? So this is shown in both degrees and radians in these here. So this is radians and this is degrees. So they are both equivalent to each other. One is just in radians and the next is in degrees. So we can see that the first quadrant, we have theta being between 0 and pi over 2 radians. The second quadrant, theta being in between pi over 2 and pi radians, and then so on and so forth. And the equivalent is the first quadrant, theta is between 0 and 90 degrees, second between 90 degrees and 180 degrees, the third quadrant 180 degrees and 270 degrees, and the final fourth quadrant 270 degrees and 360 degrees. And then of course we know that pi radians is equal to 180 degrees. So that is just the conversion. Okay? We can tell the sign of our trigonometric functions, sine, cosine, and tangent, depending on the quadrant it is in, right? So it changes depending on the quadrant that it is in. The sign meaning positive or negative. Okay, so the positivity or the negativity of the function can be given, well, told, based on the quadrant, one of the 4 quadrants that it is in. So if we were to draw a unit circle is just a circle with center 0, 0 and a radius of 1. So we can see 1 along the x and y axis, right? So using the triangle drawn in the first quadrant, we just focus on the first quadrant in this example, we can see that sine would be positive, cos would also be positive, and tan positive. So all functions are positive in the first quadrant. However, this is not the case for all the quadrants. We can see here, if we repeat the process for each quadrant, 2, 3, and 4, we'll be able to figure out which functions are positive and negative. And again, I know that some of you will know this. All school teachers cuss. Okay, so going the counterclockwise direction, we can tell that sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant, where the rest are just negatives. And the first quadrant, of course, all are positive. So you can remember that by all school teachers. I'm gonna put cuss, but I think you all know what we mean by that. So all school teachers cuss, right? So we go in like that, and that's how we remember the positivity and negativity of functions in certain quadrants. Now that we have a solid understanding of the fundamentals, we're going to move on into how to actually solve the equations. Now, regardless of the type of equation that we are solving or the method that we choose, we have one objective, and that is to reduce the equation into one of the 3 forms. The 3 forms are as such: cos theta is equal to k, sine theta is equal to k, and tan theta is equal to k. And this is so we can then go on to finding the value of theta or solving the equation. Alright? Unfortunately, if there are 2 different trigonometric functions in one equation, we cannot find the value of the angle. So we must be able to reduce it into one trig function to be able to solve it. There are three types of trig equations that we may encounter. The first type is simple trig equations. Looks like this. The second type is trig equations in the form of a quadratic. And the third type is trig equations of the form acosθ plus bsinθ is equal to c, which will be covered in the next video. The first case, simple trigonometric equations. When we are solving simple trig equations, there are two scenarios that we can encounter. The first scenario is if we are asked to prove an identity before being asked to solve that particular equation. Okay, so in this example, we have part 1 and part 2. Okay, so the first part says to show that sec theta minus tan theta sine theta is equal to cos theta. What this is asking us is to prove an identity. And the reason for this is because in part 2, we are able to utilize that particular identity by substituting it, and then it will make it much easier for us to solve the equation. So you'll see that now. In part 2, they're asking us to solve this equation, right? And notice that since this here is equal to cos theta, we can just say that cos theta is equal to the square root of 3. Alright, so the solution, the first part, we actually prove the identity, right? So to be able to do this, we use other identities, of course, and simplify it. And then when we actually prove the identity, QED, we will be able to substitute cos theta and then be able to solve for theta much easier, and then obviously solve the equation. The second scenario is actually if we are not asked to prove an identity and we are just asked to find the value of theta, which is very unlikely, but it could possibly happen. So that is basically just jumping to this step here and ignoring the identity being proven. Case number 2. Trig functions in the form of a quadratic. So typical trigonometric functions that are in the form of a quadratic will involve two different trigonometric functions, and we will have to connect them using our identities. Again, the previous video is very, very helpful for that. For example, if we are given an equation in terms of tan and sec, we remember that the identity sec squared theta is equal to tan squared theta plus 1. Therefore, we can use this to put the equation in terms of one trigonometric function. So let's look at an example. We're going to use a different set of trig functions, sine and cos, in this example. We remember the identity sine squared theta plus cos squared theta is equal to 1. So in this example, we're asked to solve this quadratic, right? So this is a trig function in the form of a quadratic. A trig equation in the form of a quadratic, sorry. So in this equation, we have the terms in sine and cos. We're going to use this identity to put it in terms of one function. So we are then able to put it in terms of cos, and now we can solve the equation. So there are basically certain protocols that you have to go through. So this is one, putting it in terms of one function to then be able to solve it. So that is where identities come in very, very handy. And the third case, last but not least, will be covered in the next video. Now, there are three methods that we can use to find the value of the angle or to solve the equation, right? The first one is general solutions. The second one is the graphs, which we just covered, and the use of our knowledge of the quadrants, which we also just covered. But now we're going to learn about general solutions. So when solving trigonometric equations, there are principal solutions and general solutions. However, principal solutions lie in this interval only. So the interval 0 and 2 pi. We know that this does not represent all values. However, general solutions give us a way to represent all the values which would satisfy a particular equation. And in my opinion, I believe that it is the most convenient as well, although it is not the only method that we can use. Okay? So we're going to look at the general solutions for sine, cosine, and tangent. So given that sine x is equal to k, we're using x, this could also be theta, we're just using x. When k is between -1 and 1, x is equal to n pi plus -1 to the power of n alpha. So we actually just need to find the value of alpha, and alpha is the inverse of sine k. Okay? And then we substitute it into this, which is the general solution. Okay, so x, that's the value. So the value of alpha must be between -pi/2 and pi/2, and then n can be any integer, and then we will be able to get our general solution of the equation. For cosine, if we look at cos x is equal to k, and k is between -1 and 1, x is equal to 2n pi plus or minus alpha, where alpha is equal to the inverse of cos k, and n can be any integer, the same. So for tangent, I think this is definitely the simplest one. X is equal to n pi plus alpha, given that k is between -1 and 1, and alpha is equal to the inverse of tan k. The value of alpha, of course, must be between these values, and n can be any integer. We're going to look at examples of that later. But one very important thing, radians or degrees. I think everyone asks that question all the time, and I'm going to answer it now. So the constraint for the angle given in the question will dictate whether we use degrees or radians. So if the question gives you the constraints for theta in terms of radians, for example, if we see theta is in between 0 and 2 pi, then our calculations will be done in radians. For degrees, it's the same thing. So similarly, if the constraints are given in terms of degrees, example 0 degrees and 180 degrees, then we can calculate our solutions in terms of degrees. Now on to our favorite section of the video, past papers. We're going to begin our journey with 2021. 2021 states to solve the equation cos theta is equal to sine theta minus pi/3 for theta. And this is 8 marks. The solution begins as such. We write over our equation. I always write it over just because I like to see it in my handwriting. So the first thing we'd notice here is that there are 2 different trigonometric functions in this equation, and we don't want that. We want to bring it to one trig function to be able to solve the equation. So we have to recall our compound angle formula for sine, because we notice that sine is in this form, so then we can apply this formula, right? So we put it in terms of this, where A would be theta, and b would be pi/3, and we put it in these terms using the formula, and we can simplify it to sine theta a half minus cos theta the square root of 3/2. So we can now substitute it into our equation, right? So before we had cos theta equal to this, and it is the same thing as this, just in different terms, okay? So now we're going to move all the elements to one side and have the equation, we'll have the elements equate to 0. We're going to group all the like terms, and that would be cos and cos. So we put them into one term, and then, of course, it would still be equal to 0. We can now simplify the equation, noticing that there is a denominator of 2, and we put it into all one term now. So notice how it's getting much simpler in the end, right? And the main goal is to actually get it into one trig function, which you'll see how we're going to do that now. So after multiplying throughout by 2, we will get this. So cos and sine. And now what we need to remember is what relates these two trig functions is a third one. Tan theta is equal to sine theta over cos theta. Remember that from the beginning. So we use this identity and divide throughout by cos theta in as such, like here. We do it there, and we can cross out the cos, and we get minus sine theta over cos theta. And we know that this is equal to tan theta. So notice how we went all the way from this to this. Much easier on the eyes, isn't it? Yes. So now we have one trigonometric function, which is tan theta is equal to square root of 3 plus 2. And now we can solve for theta. However, when we do solve for theta, this would only be a principal solution. So remember, the principal solution only covers the solutions that lie in the interval 0 and 2 pi. It is not representative of all solutions. However, the general solution is. So now we're going to do that because we have it in the form tan, remember the form tan x is equal to k. So we have this in the form where k is equal to root 3 plus 2. Alright, so we're going to start finding our general solution. To do so, we're going to find the value of alpha, which luckily for us we already found, and we just write it over here and we plug it right into our general solution, and that is it. That is how we solve this question for 2021. So our solution is as such. Theta is equal to n pi plus 5 pi over 12, and that is the solution. 2019 asks us to solve the equation 5 sec theta minus 2 sec squared theta is equal to tan squared theta minus 1 for theta being in between minus pi and pi. The first thing that we notice is that there are two different trigonometric functions. This is tan and sec. We don't want this. Instead, we want 1. So we're going to find an identity that relates both of them. And in this case, it is tan squared theta plus 1 is equal to sec squared theta. Now we're going to manipulate this identity to be able to substitute it and then simplify. Alright, so notice how we turned this with tan in it to only sec by using this identity. Alright, that's what we always want to do. We want to be able to use these things and manipulate them to be able to substitute it to get what we want. So after we substitute and simplify, we notice that we have a trig equation in the form of a quadratic. And we know this because of this square here. So to make it easier on the eyes, we like to usually see things simpler, right? So we're going to substitute y is equal to sec theta. And there we have a traditional quadratic equation. So we know how to do this. We factorize and we get our two values, minus a third and 2. So we also recall that sec theta is equal to 1 over cos theta. How do we know that? The third letter and the first letter are the same, okay? So for this one, cos theta is equal to minus 3. There is no solution. We could take a look at that using the graph. And remember, for the general solution, when the equation is in the form cos x is equal to k, k has to be between minus 1 and 1. So if the value is larger than 1 or smaller than minus 1, there will be no solution to the equation. So for this one, there is no solution. Or cos theta is equal to a half. So this is of the form cos theta is equal to k. So therefore we can apply our general solution. Recall the general solution for cos theta is theta is equal to 2n pi plus or minus alpha. So the first thing we do is find alpha, and that happens to be pi over 3. Remember, to do that, it's the inverse of cos k, right? So k is a half, so we simplify and find that. So our general solution represents all possible solutions to the given trigonometric equation. However, the question asks us to find the values of theta between minus pi and pi, so we were given constraints. Recall that n can be any integer, a whole number. Therefore, to find the values of theta that satisfy the constraints given, we must substitute different values of n into our general solution. Alright, so we start with n is equal to 0 and work our way up and down to find the value of theta that satisfy the given constraints, which in this case is minus pi and pi. So when n is equal to 0, again, we're just putting in random numbers at this point, and we start at 0. So when n is equal to 0, theta is equal to these values. When n is equal to 1, theta is equal to these values. So given the constraints, we can say that theta is equal to minus pi over 3 and pi over 3. So that is our answer. 2018 asks us to solve this equation. And they give us constraints again. Now this equation, the first thing I want you to ask yourself, again, same or different trig functions? Different? Okay, we need to make it the same. So we have sine and cos. What relates sine and cos? What identities do we know? We know sine squared theta plus cos squared theta is equal to 1, and tan theta is equal to sine theta over cos theta. So immediately thinking about that, we know that we need to use something to make it into one trig function, right? All in terms of one trig function. So we're going to recall this particular identity, and now we're going to think ahead. We're going to square both sides to be able to apply this identity later on. So after doing that, we simplify. We're going to manipulate this identity into sine squared theta is equal to 1 minus cos squared theta. We're going to substitute that and bring all the terms to one side. After simplifying that, we are going to get it in terms of a quadratic. So this equation is in terms of a quadratic now because of this square. What do? We put it in terms of y. And this is because it's just easier for us to look at. So let cos theta is equal to y, and that will just make it easier to look at, right? So 2y squared plus root 3y is equal to 0. We find our values of y, and then of course we equate it back to cos theta. And since both of these are in the form of cos theta is equal to k, what can we do? Exactly, general solution. The general solution for cos is theta is equal to 2n pi plus or minus alpha. So we find alpha, and then we can apply our general solution. So we find an alpha in both cases and applying our general solutions. Remember to put it in your calculator, and what do? Double check if it is in degrees or radians, and as I explained before, when we use degrees or radians, okay? So we find our general solution, but remember we have constraints. So we substitute our values of n, usually starting from 0 and then going up or down to find where our solutions may lie. So given constraint, based on that, our values for theta would be plus or minus pi on 2 or plus or minus 5 pi on 6, and that is 2018. The next past paper we're going to look at is 2017, and this asks us to solve the equation sine squared theta minus 2 cos squared theta plus 3 cos theta plus 5 is equal to 0 with these constraints. That will give us 6 marks if we get it correct. So the first thing that we notice, again, two different trig functions, and these are sine and cos. Similar to the previous past paper, we are going to use this identity. Alright, we're going to manipulate sine squared theta plus cos squared theta is equal to 1 to get sine squared theta is equal to 1 minus cos squared theta. And now we're going to substitute that and simplify. We simplify to get minus cos squared theta plus 3 cos theta plus 6 equal to 0. We notice that there are a lot of 3's or a multiple of 3, and therefore we divide throughout by 3 to be able to simplify it further. So we'll end up with this, which we can tell already is in the form of a quadratic. So easier on the eyes, cos theta is equal to y. So we have minus y squared plus y plus 2 is equal to 0. We get our two values for y and go back and equate them to cos. Now we're going to use our vast knowledge of graphs. So we know what our cos graphs look like. So we have cos theta is equal to minus 1 as well as 2. So the minimum value of cos theta is minus 1, and this occurs when theta is equal to pi, right? So we know as well that the max value of cos theta is equal to plus 1, therefore there is no solution for cos theta is equal to 2. That is irrelevant. But we can also note that cos theta is a periodic function, so that means it repeats itself every 2 pi radians. So therefore, to find the value of theta that satisfies, remember we were given constraints, and this was the boundary. So to find the value of theta that satisfies cos theta is equal to minus 1, for this constraint, we can add 2 pi. So therefore, we have the values of theta to be pi as well as 3 pi. At this point in time, I highly recommend you pause the video and try to solve 2016 on your own, because I'm going to do it with you shortly. So pause it now, and when you're ready, when you're finished, try your best to apply everything we've already learned, and then when you're finished, unpause the video because we're gonna start the solution now. Okay, in 2016, we have two parts that were related. So in part 1 of the question, they ask us to prove this identity. And we know that it is related to part 2 because the right-hand side of this identity is the same as the left-hand side of this equation. And that is very, very convenient for us because we can simply substitute this entire thing for sec squared theta. So that's the first thing we're going to do. That makes our lives much easier because, as you can see here, it's in the terms of sine and cosec, which is what we didn't want, but now we get it in terms of sec squared theta, which is just one trig function. So that's the first thing we're going to do. We're going to write that sec squared theta is equal to 4/3, and that is from part 1, right? Remember, we proved that identity. Okay, we also can recall that 1/cos theta is equal to sec theta. So we can say that 1/cos squared theta is equal to sec squared theta. So we can replace that immediately because remember, we want to get it in terms of sine, tan, or cos. Okay, now we're going to flip these to get cos squared theta is equal to 3/4. And from here, we can get rid of that square. So cos theta is equal to plus or minus the root of 3/4. And we can recall this handy little rule. And we're going to apply it now. And we know that we can simplify √4 because we all know that that is equal to 2. And we actually have two values already. So the first being positive 3/2, and then negative √3/2. And the first thing that we notice here is that it's in the form cos theta is equal to k. So cos theta is equal to k, cos theta is equal to k. And we know that our general solution for cos is 2n pi plus or minus alpha. So we have both of these going here. And the first thing we're going to do is find the value of alpha. So for the left, we have alpha is equal to the inverse of cos positive 3 on 2, and then this one. We're going to do both simultaneously because I just feel like it's quicker. One page, one thought process. And now let me work out these values. If you haven't already, I strongly urge you to always practice using your calculator as well. Very, very useful. So it's much quicker when you actually get into the exam. Right, now that we have our values for alpha, we have to recall if we have any constraints. And I'm pretty sure that we do. And yes, we do. So we have theta between 0 and 2 pi. Okay, so this now we are going to use n equal to 0. And let's start substituting to see if we can find some values. Okay, so now we have values and we know that these two definitely don't fit our criteria, which is 0 is less than or equal to theta is less than or equal to 2 pi. So these two wouldn't suit. And let's just do the second one as well. So let me start substituting here. Now we have all these values and we notice that these here do not satisfy our criteria. These and these. So we are going to exclude them and we have our values. So we have our answer. Our solution is therefore theta is equal to pi over 6, 11 pi over 6, 5 pi on 6, and 7 pi on 6. And if we want to be a little extra, we can reorder them. And that looks much nicer. And that is our solution. So there we have it. That, my friends, was 2016.